Hi, everybody. It's Professor Mitchell. We're continuing today Chapter 2 on polynomial and rational functions. And today we are talking about Section 2.4, dividing polynomials and the remainder and factor theorems. In this section, we will use long division to divide polynomials, use synthetic division to divide polynomials, which is a shortcut that you can use sometimes. We'll evaluate a polynomial using the remainder theorem, and we'll use the factor theorem to solve a polynomial equation. All right, so we start off with the division algorithm. The division algorithm says that if f of x and d of x, think d for divisor, are polynomials with d of x not equal to 0, and the degree of d of x is less than or equal to the degree of f of x. Then there exist unique polynomials q of x and r of x, q and r for quotient and remainder, such that f of x equals d of x times q of x plus r of x. Now, this sounds very complicated, but in fact, you know a version of this for numbers. I'm going to switch over to my tablet here for just a second. Here we go. All right, so there is a division algorithm for numbers, and what it says is that when you divide a number by another number, let's say 587 divided by 8, then there exists a unique quotient and remainder. And of course, you find that quotient and remainder by doing long division. So 8 goes into 58 7 times. 7 times 58 is 56. Subtract, get 27. 8 into 27 goes 3 times. And the remainder is 3. So what's special about 3 is that it's greater than 0, greater than or equal to 0, I should say, and strictly less than 8. All right, and there are a couple of different ways that you can tie these four numbers together. The one that goes along with what we're talking about on the other slide is you can say that 587 is equal to the divisor times the quotient plus the remainder. You can also say that 587 over 8 is equal to the quotient plus the remainder over the divisor, okay? And this way right here kind of corresponds with how we're going to write our answers when we do polynomial long division. All right, so switching back to the slides. Okay, so continuing with the division algorithm, the remainder r of x either equals 0 or it is of degree less than the degree of d of x. If r of x is equal to 0, then we say that d of x divides evenly into f of x, and that d of x and q of x are factors of f of x. So as long as you require the degree of the remainder polynomial to be less than the degree of the divisor, then these two polynomials, q of x and r of x, are unique, just like it says here. So that's actually really special. And by the way, the same thing is true for numbers. As long as you require your remainder to be less than your divisor, then the quotient and remainder numbers are unique. All right, so I'm not going to spend a whole lot of time on these two slides because this is talking you through the steps of doing polynomial long division, and really this will make a lot more sense when you actually see it done, okay? All right, so first arrange the terms of both the dividend and the divisor in descending powers. Divide the first term in the dividend by the first term in the divisor, and the result is the first term of the quotient. Then you multiply every term in the divisor by the first term in the quotient and write the resulting product beneath the dividend with like terms lined up. And then subtract that product from the dividend. All right, so just remember, divide, multiply, subtract. Because you're going to do those three things on a loop, basically until you run out of terms in your dividend. So bring down the next term in the original dividend and write it next to the remainder to form a new dividend. Use this new expression as the dividend and repeat the process on the previous slide. Divide, multiply, subtract until the remainder can no longer be divided. This will occur when the degree of the remainder is less than the degree of the divisor. All right, so here's our first example. We're going to divide 7 minus 11x minus 3x squared plus 2x cubed by x minus 3. So I'm going to do all of these division problems on the tablet. Notice first we have to start by writing the dividend in descending powers of x. Because really this is not going to make any sense to you at all if I just show you this. Even if I talk you through it, it'll make a lot more sense if you actually watch me do it. So I'm going to switch over to the tablet where I already have this problem written down. And there it is. So what you might want to do while you're watching this is not try to take any notes. Just watch and listen. And then at the end, you can pause the video. I'll tell you when I'm done. And, and then take all the notes that you want. Okay, this is definitely what I call a watch, don't write. Okay. All right, so we've got the terms of the dividend written in descending order. So what I am going to do first is divide x into 2x cubed. All right, so 2x cubed divided by x is 2x squared, right? So now I'm going to take that 2x squared and I'm going to multiply it by x minus 3. So 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. All right, so we've done the divide, we've done the multiply, now we have to subtract. Now it's very, very important to subtract the whole thing. Okay. So subtract the whole thing. So I've written that product in parentheses. All right, so that's going to go 2x cubed minus 2x cubed will cancel, and those two should always cancel. And then negative 3x squared minus negative 6x squared, that's like negative 3x squared plus 6x squared, that's going to give me 3x squared. All right, so that's just about one full cycle of the divide, multiply, subtract. So what I'm going to do now is bring down the rest of my terms in the dividend. I'm going to bring down the minus 11x and the plus 7. And now I'm going to repeat the whole process. Okay, so I'm going to divide x into 3x squared, and that's going to give me 3x. So that's divide. Now I multiply. 3x times x is 3x squared. 3x times negative 3 is minus 9x. And now subtract the whole thing. All right, so 3x squared minus 3x squared cancels. Those two should always cancel. Negative 11x minus negative 9x is the same thing as negative 11x plus 9x. That is negative 2x. And now bring down the plus 7. All right, one more time. Divide, multiply, subtract. We're going to divide x into negative 2x. Negative 2x divided by x is negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Subtract the whole thing. Negative 2x plus 2x cancels. Those two should always cancel. And then 7 minus 6 is 1. And that's going to be my remainder. One thing I like to tell classes is that you know you're on the last cycle of divide, multiply, subtract when you see a constant term appear in the quotient. That means you're on your last step. All right, now in terms of writing the answer, here's how we're going to write it. We're going to write the quotient, which is 2x squared plus 3x minus 2. And then we're going to write plus the remainder, which is 1, over the divisor, which is x minus 3. So that's how you write your answer for a polynomial long division problem. So at this point, I will let you pause the video if you want to take some notes, and then just come back when you're ready. I will switch back over to the slides. All right, so here's how they wrote it out. Basically the same thing as what I wrote. I wrote it maybe a little differently. All right, so here's another example. I want to give you a head start on this one, but I do want to give you a hint. Notice that both the dividend and the divisor have a missing term. Neither one of them has an x term. So when you're doing long division, it's a really good idea to put a placeholder wherever there's a missing term. So I'm going to go ahead and show you how I have this set up. And then I want to encourage you to pause the video and try to do this one. Here we go. Okay, so that's how the setup looks. So x squared plus 1 becomes x squared plus 0x plus 1. And 2x cubed minus 4x squared minus 6 becomes 2x cubed minus 4x squared plus 0x minus 6. And when you do this problem, hopefully you'll see why that placeholder is so important. So go ahead and pause the video and try this one, and then come back and we will compare notes. All right, so hopefully you've had a chance to try that. I'll do this one just a little faster. All right, so first step is x squared into 2x cubed. 2x cubed divided by x squared goes 2x. Now multiply. 2x squared times, 2x times x squared is 2x cubed. 2x times 0x, I'm going to write that as 0x squared. 2x times 1 is 2x. All right, so the reason that I want the placeholders is because if I had just had an x squared plus 1 over here, this multiplication would have given me 2x cubed plus 2x, which of course is correct, but I have a feeling the 2x probably would have ended up in the wrong spot. It would have ended up maybe under the negative 4x squared, okay? We always want like terms to line up. So now I'm going to subtract the whole thing. 2x cubed minus 2x cubed cancels. Those two should always cancel. Negative 4x squared minus 0 is negative 4x squared. 0 minus 2x is negative 2x. And I'll bring down minus 6. All right, so now we'll do it one more time. So the next question is, how many times does x squared go into negative 4x squared? The answer is negative 4. Negative 4 times x squared is negative 4x squared. Negative 4 times 0x is 0x. Negative 4 times 1 is negative 4. Subtract the whole thing. These two cancel. They should always cancel. Negative 2x minus 0 is negative 2x. Negative 6 minus negative 4 is negative 6 plus 4, which is negative 2. All right, so now I'll go ahead and write my answer. The answer goes in the form quotient, which is 2x minus 4 plus the remainder over the divisor. Now, when I'm sitting in a class or standing in a classroom, a lot of times student will ask me, hey, Mitchell, can't you just write that answer as 2x minus 4 minus 2x minus 2 over x squared plus 1? And the answer is no, you can't. Do you see why not? This minus here only applies to the 2x, but if you put a minus in front of the whole fraction, it applies to the 2x, the whole entire 2x minus 2. If you really wanted to make this look prettier, and I don't encourage this, what you would need to do is change this 2x minus 2 to 2x plus 2. But it's really more common to just always make this sign a plus and then just write the remainder exactly the way it comes out. All right, back to the slides. I think we are ready to talk about synthetic division. I love synthetic division. So synthetic division is a shortcut that you can use some of the time, not all the time. Doesn't it say? Okay. All right. Well, I kind of want to start with something that it says in step 2, actually. So synthetic division can only be used when the divisor has the form x minus c. Now, what I mean by x minus c is not only like x minus 2 and x minus 4, but also something like x plus 1 or x plus 5. Those are okay too. Any divisor whose leading term is x, okay? That's the only time you can use synthetic division. All right, so we're going to start by arranging the polynomial in descending powers with a 0 coefficient for any missing term. And in synthetic division, that's actually required, all right? You absolutely have to have those placeholders. Otherwise, you're actually doing a different problem, okay? We don't want to do a different problem. We want to do the problem that's given. All right, so write C for the divisor x minus c. Now this part usually creates a little bit of confusion at first, but we will get past that. And then to the right, write the coefficients of the dividend. And of course, this will make a lot more sense when you see me do it. Write the leading coefficient of the dividend on the bottom row. And then you do this cycle of 2 operations just back and forth. You multiply c times the value just written on the bottom row and write the product in the next column in the second row, all right? And then add the values in that new column together, writing the sum in the bottom row. Repeat this series of multiplications and additions until all columns are filled in. And then use the numbers in the last row to write the quotient plus the remainder over the divisor. The degree of the first term of the quotient is 1 less than the degree of the first term of the dividend. The final value in that row is the remainder. Okay, so if you didn't take any of that in, it's fine because I'm going to show you how to do it right now. So we're going to use synthetic division to divide x cubed minus 7x minus 6 by x plus 2. And actually, I just realized it would come in handy. I have the problem set up on my tablet already, but I think it would be, might make things a little clearer if I actually write this original problem. Okay, so let's switch over to the tablet. Here we go. All right, so this is how you set up synthetic division. I have -2 written down to represent x plus 2. Now this is the part that seems to confuse everybody when they first start synthetic division. Remember that the divisor, we're thinking of it as having the form x minus c. So I'm thinking of that x plus 2 as x minus -2. So it's the -2 that I want to put over here. Okay. The other part I think is a little more clear. The 1, 0, -7, -6 are the coefficients of x cubed minus 7x minus 6. Notice that the 0 is the coefficient of x squared. And as I said, you absolutely have to have that 0, otherwise you're doing a different problem. All right, so once again, you might want to watch and not write. Take all your notes at the end. So here's how this goes. You start by bringing down the first number, just bring it all the way down and write it here. And then I'm going to multiply. -2 times 1 is -2. And now I'm going to add those two numbers together. 0 plus -2 is -2. And now just repeat those same two things, the multiplications and additions. So now I'm going to go -2 times -2 is +4. And I'm going to add -7 plus 4 is -3. And one more time, I'm going to multiply. -2 times -3 is +6. -6 plus 6 is 0. All right, so the 0 is the remainder. And you can either think of the quotient the way they said, that this is the leading coefficient of the quotient, and it has degree 1 less than the degree of the dividend, so that means x squared. Or the way I like to think of it is just read it from right to left. This is your remainder, this is your constant term, this is your x term, this is your x squared term. Okay. The answer is written just the same way that we wrote our long division answers. We write the quotient plus the remainder over the divisor. Remember, the divisor was x plus 2. Now, in this case, the remainder is 0, which means you really don't need that fraction. You can just write this answer as x squared minus 2x minus 3. All right, so that completes that problem. Go ahead and pause the video and take some notes if you've just been watching, which I hope you have. We're going to do another example next. Actually, I'm going to give you first crack at it, so you will have a chance to practice this. Okay, so let's grab that example. Okay, here is how they wrote it. So yeah, if I had just tried to talk you through this, I don't think it would have made a lot of sense. Okay, so here's an example that I made up. We're going to use synthetic division to divide 5x cubed minus 6x squared plus 3x plus 11 divided by x minus 2. So please pause the video and try to set that up. Actually, maybe I will have you do this in two parts. So first try to set it up, and then once you've got it set up, unpause the video. I will show you the setup, and then you can pause it again and try to actually do the synthetic division. Okay, so first step, set it up. Come back when you're finished. Okay, so let me show you what my setup looks like. Hopefully you got the same thing. Okay. No missing terms this time, so you don't see any zeros. And what's outside is a 2 because the divisor was x minus 2. We think of our divisor as x minus c. So that just matches up perfectly. All right, so now pause the video again and try to actually do this synthetic division. And when you're finished, come back and we'll compare notes. All right, here we go. So the first thing I'm going to do is bring down the 5. And then I'm going to go 2 times 5 is 10. Negative 6 plus 10 is 4. 2 times 4 is 8. 3 plus 8 is 11. 2 times 11 is 22. 11 plus 22 is 33. How'd you do? All right, now we still have to write the answer, right? So this is your remainder. This is your constant term. This is your x term. This is your x squared term. So this time the answer is going to look like 5x squared plus 4x plus 11 plus 33 over the divisor, which is x minus 2. And this time, of course, I do need that fraction part because my remainder is not 0. All right, let's see what else we got. Okay, little spoiler there. Okay, review of evaluating functions. So I want you to do this. You don't need me to tell you how to do this. I will do it on the tablet. And let's see what happens, all right? Somehow this probably relates to what we've been talking about. So the first problem is if f of x is x cubed minus 7x minus 6, we want to evaluate f of negative 2. And the second problem, if g of x, sorry, I'm trying to talk about one thing and write something else. If g of x is 5x cubed minus 6x squared plus 3x plus 11, we want to evaluate g of 2. So go ahead and try that. And when you're finished, come back and we will compare notes. Sorry, just writing down the rest of the problem. Didn't think to write this one down ahead of time. All right, here we go. Okay, so you know how I like to do my functions. I like to write them without the x and then fill in the x afterwards. Okay, so in the first problem, we are replacing x with negative 2. So I am going to put a negative 2 there. Okay, so what do we get? We get the cube of negative 2, which is negative 8, minus 7 times negative 2, which is plus 14, minus 6. Negative 8 plus 14 is 6. 6 minus 6 is 0. Okay, so now we'll do the next one. G of blank equals 5 blank cubed minus 6 blank squared plus 3 blank plus 11. And now let's use a different color this time. All right, G for green. Now pay attention to how much stupid arithmetic I have to do in order to get this answer, right? 2 cubed is 8, 5 times 8 is 40. 2 cubed squared is 4, 6 times 4 is 24. Plus 3 times 2 is 6, plus 11. 40 minus 24 is 16. 16 plus 6 is 22. 22 plus 11 is 33. Now I'm starting to have some deja vu. Where have I seen those answers before? Let's see. Oh, well, we're not going to see it on here. 33 was the remainder to this division problem, and 0 was the remainder to this division problem, which is why I have, all right, that is not a coincidence. And actually, the explanation is pretty simple. I don't want to bother you with it right now, but it might be a good thing for discussion if you're taking an online class with me. All right, so it turns out that whenever you divide the polynomial f of x by x minus c, the remainder will always turn out to be f of c. And so this is important for a couple of different reasons. First of all, and this is hard to believe when you're first learning synthetic division, but doing the synthetic division is actually a whole lot less work than doing all that stupid arithmetic with the, plugging the number into the function, right? That's not the most important, thing about the remainder theorem. It's just, right, that'll come out in a little bit. In the meantime, we have this example. Given f of x equals 3x cubed plus 4x squared minus 5x plus 3, we want to use the remainder theorem to find f of negative 4. Now, if you're taking a class with me, this is the kind of problem where I will always check your work, your written work, because I don't know if you use the remainder theorem unless I look at your written work. You could do this problem some other way and get the correct answer. And if I'm just checking the answer, I would never know. All right, so we are going to use synthetic division. The remainder theorem says that the value of f of negative 4 will be the remainder when this polynomial is divided by x minus negative 4. Okay, so notice I said x minus negative 4, which is why you have the negative 4 out here. All right, so this time I won't do it on the tablet. We'll just follow along with it here. So bring down the 3, and then negative 4 times 3 is negative 12. 4 plus negative 12 is negative 8. Negative 4 times negative 8 is 32. Negative 5 plus 32 is 27. Negative 4 times 27 is negative 108. And then 3 plus negative 108 is negative 105. And you could check this answer by, doing it the other way, actually replacing all the x's with negative 4s. Hopefully you'll agree that it's actually more work doing it that way. This was very easy. You're only ever doing two things. You're multiplying by negative 4 and adding, all right? You have to do a whole bunch of other stuff when you do it the old way. All right, so that remainder, negative 105, is the value of f of negative 4. All right, and we have one last thing to look at in this section. If f of x is a polynomial, then basically I can summarize these two statements in one. This says basically that f of c equals 0 if and only if x minus c is a factor of f of x. So the way that we're going to use this is for factoring. Whenever we want to see if a given, let's say, binomial is a factor of a bigger polynomial, we will use synthetic division and see if the remainder comes out to be 0. Okay, so for example, in this problem, they want us to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that the number -1 is a 0 of the polynomial f of x equals 15x cubed plus 14x squared minus 3x. Oh, I'm so sorry. That is supposed to say, I'm surprised I never caught that before. I probably did when I was standing in front of my class. That's supposed to be a minus sign. Okay. All right, so we are given that negative, they did it again down here, didn't they? We are given that -1 is a 0 of the polynomial f of x equals 15x cubed plus 14x squared minus 3x minus 2. Which means that f of -1 is 0. Because f of -1 is 0, the factor theorem tells us that x plus 1 has to be a factor of f of x. So we're going to use synthetic division to divide f of x by x plus 1. And that looks like this. Remember, x plus 1 is represented by a -1. So we bring down the 15. -1 times 15 is -15. 14 plus -15 is -1. -1 times -1 is +1. -3 plus 1 is -2. -1 times -2 is +2. -2 plus 2 is 0. And that should not be a surprise because they told me that they told me that -1 is a 0 of this polynomial. So I was expecting this remainder to be 0. If it didn't come out to be 0, that means there's either something wrong with this problem or I made a mistake. All right, so reading off this answer over here, we get that 15x cubed plus 14x squared minus 3x minus 2 divided by x plus 1 is 15x squared minus x minus 2, which equivalently can be written like this. So now all we have to do is just factor the rest of 15x squared minus x minus 2. All right, so that's going to happen on the next slide. All right, so I got something in my way here. There we go. All right, so 15x squared minus x minus 2 factors into 3x plus 1 times 5x minus 2. So factoring is hopefully something that you're an expert at. We review it in our trigonometry course, which hopefully you've taken. If not, hopefully you're an expert from other math classes that you've taken before. Maybe just very briefly, I'm not going to do this entire factoring problem. That would be, I guess, another thing to ask about in the discussion if you want more details. But the way that most people seem to like to do it is like this. You make the big X diagram, look for numbers that add up to -1, and multiply to 15 times -2, which is -30. All right, those two numbers would be what? 6 and -5. And then you use the 6 and the -5 to factor this thing by grouping. All right, just very, very briefly, 15, you would rewrite this as 15x squared plus 6x minus 5x minus 2. And then you would factor that thing by grouping, and you would get 3x plus 1 times 5x minus 2. Hold on a second, I lost my mouse. And it's always hard to find when I've been using the text box. Oh, wait, almost found it. There we go. There we go. Got it. Okay. All right, so this thing has 3 factors. Remember, we're trying to figure out when does this polynomial equal 0. All right, well, it equals 0 when at least one of these factors is equal to 0. If x plus 1 is 0, that means x is negative 1. If 3x plus 1 is 0, that means x is negative 1/3. And if 5x minus 2 is 0, that means x is 2/5. So the solution set of this equation is negative 1, negative 1/3, and 2/5. And I believe that is it for section 2.4. So we will see you next time.